Hi, this is Mr. Max with Sun Go for Mathematics. Now, this is the second part of my three-part series on revision type questions or examination type questions that you're going to get in trigonometry. Right, so you have a diagram here. As you can see, you have the tangent and then you have the cosine function, and somewhere they are intersecting at points A and B. And your domain is only from 0 radians to pi radians, or 0 degrees to 180 degrees. So if you were to go and work this question, you need to make sure that your calculator is in radian mode because the domain is in radians. The first part, they're asking you to calculate the x coordinate of A, so we're just looking for the x coordinate there. The second part, they will ask you to calculate the coordinates of B. That means you give the x, that angle there, as well as this distance, right, this ratio, or whatever that distance would be. Well, by just looking at where point B is, you do expect that the y value should be negative. Those are obviously common sense. And then also you have that the angles must be positive because you have got from 0 to pi radians or 0 degrees to 180 degrees. Okay, you can have a go and then pause the video, and after a while you can see what I have done. Alright, so let's start off with the intersection. Where these two functions are intersecting, they are exactly equal. That means the tangent of x is equal to the cosine of x, right? So you know that tangent can be written as sine x over cos x, and what I do here is just I multiply throughout by cos x. I get cos square x equals to sine x. Right, I want everything to be in terms of sine x, so I hope you still remember for your Pythagorean square identity that sine square x plus cos square x is equal to 1. Making cos square x the subject of the formula, that I'm going to retain 1 minus sine square x is equal to sine x. So this becomes like a quadratic equation, which is sine square x plus sine x minus 1 equals to 0. Okay, so let that distance be equal to k, the sine x, so that we have an equation that makes rather sense. But you know, this k squared plus k minus 1 equals to 0 does not factorize, so you have to use completing the square or the quadratic equation formula. So I'd like to work out the discriminant, but remember the discriminant is just that value under the root, okay? And then you put in your b and you put in your a. Well, you should arrive at these particular values here, that k is equal to 0.618 and negative 1.618. Right. Okay, so let's just, this is k, but we're not looking for k, we're looking for sine x. So let's bring sine x back. So that means we are going to look for the angle. But now, before we continue with that, please remember our domain was from 0 to 180 degrees or pi radians. And the sine is positive only between 0 and 180, that is in the first two quadrants. So this sine x is equal to negative 1.61803 will not be considered. Okay, I hope you still remember from your cos diagram. So remember, your calculator should be in radian mode. Our acute basic angle is 0.6662 radians. So one solution will be that, and the other solution will be pi minus that 0.662 radians. So my x coordinate of A, and that is what they are looking for, is 0.66 radians because it is in the first quadrant. These are the value that you have here, the 2.475. If you guess it, you should be right. It is the coordinate in B, the x coordinate of B. So part B then wants us to find the x coordinate of the coordinates of B. So that is the first quadrant if you look at it that way. And the coordinate of B, you can see it's in the second quadrant. So again, as I said, we are looking for that. The angle x there is 2.475 radians, okay? Remember the value of pi is about 3.14 and so on. Okay, so that angle is 2.475 radians, but we are not just only looking for that angle, we are also looking for the y value. All right, so substitute then into the y equals cos x. All right, so that you can find what is the output. Okay, so once you do that, you're going to get negative 0.786. Good, so then the coordinate of B is 2.48 radians, comma, negative 0.786. So what if someone was trying to substitute this value here? Remember, it's in radian mode. But let's suppose we have somebody saying, okay, but why don't we substitute that into y equals to 10x, all right, since they're intersecting. So I hope that you are remembering something, okay, because we are saying that the x coordinate of P is in the second quadrant, okay, and in the second quadrant your tangent value is positive, and you can check that out if you punch tangent equals 10 of 2.475, you're going to get a same answer. You're also going to get a negative 0.786. So it doesn't really matter in which one you're going to punch it, because tangent is going to be negative in the second quadrant as well. Question 2. Well, perhaps you can pause, try to do this question on your own. It is given that A is equal to sine theta minus 3 cos theta, B is equal to 3 sine theta plus cos theta, and theta is an angle that is between 0 and 360 degrees. They say you must show for part A that A squared, that means this whole business here, plus B squared, that means the whole 3 sine theta plus cos theta, if you squared the sum of that, has a constant value for all theta. So what is that constant value? So we have to show that it has a constant. Then part B, you now have to make this an equation 2a equals to b, and then you find the values of theta, okay, for that given domain. So attempt them and see where you go from there. Okay, so I'm going to start with the first one, a squared plus b squared, and basically that's what it means. So this is actually binomial plus another binomial that you need to multiply out. So maybe you should do this some way so that you have the right stuff. So sine theta minus 3 cos squared theta means sine theta minus 3 cos theta times sine theta minus 3 cos theta. So you do this and you get to an answer, and you see what that leads you to, and you can write it down. And the other one, 3 sine theta plus cos theta squared, all squared, means that bracket should multiply by itself. 3 sine theta plus cos theta multiplied by 3 sine theta plus cos theta. So do not just multiply each by or square each thing. There are also things happening in the middle. Right, so all of that gives me all this horrible long expression here that I have. And as you do this expression, you realize that there are certain things that cancel out, like the minus 3 sin theta cos theta, minus 3 sin theta cos theta, and plus 3 sin theta cos theta, plus 3 sin theta cos theta. They cancel out, leaving me with sine square theta minus 9 square theta, sine square theta plus 9 square theta, plus 9 cos square theta plus cos square theta. So in all, it gives you 10 sine square theta plus 10 cos square theta, taking out the 10. And I hope you remember that sine square theta plus cos square theta is equal to 1. So that constant is 10. I have a third question here. Now I have done similar videos on sequences and series, but here we just spice it up by putting in some cosine and tangent trigonometric functions in there, so it still shows a progression. So try them. You have 3 questions here. Part B is divided in 2 sub questions. The first question is a straightforward question that if you know how to deal with arithmetic progression, and you should be able to find the sum to infinity. Part B, now the terms are not just numbers or things you are used to, they are actually things containing sine and cosine. So you have 2 sine x, that is going to be the first term, 3 cos x, that is the second term, and the third term is all of sine x plus 2 cos x. And then they are saying x is an acute angle. This is quite important when you are going to find the sum of the first 20 terms. Right, so let's do the first one. So I know it's a GP, and from that I know the first term is 50, and I also know that the third term is 32. And you know the general formula for a GP is ARN minus 1 power. Okay, so my first two equations I can create from this information is A is 50, AR 3 minus 1 is equal to 32. Then I will just simply substitute. There are other ways that you can do that, but you can substitute that 50 into the second one. And then you solve for that. Remember, you are going to now have to find a common ratio, and that common ratio has to be positive since the terms are positive. Okay, all the terms are positive. All right. So that means we're not going to take the negative one. So the correct R is 4.5, but we're not finding R. We'll use that to find the sum to infinity, because the formula for sum to infinity is A all upon 1 minus R. Hence, you had to find R. So now you just substitute for A, which is 50, and for R, which is 4 over 5. Therefore, the sum to infinity is 250. Here then are the two other questions, and take note I have bolded the word acute. So first thing, we are supposed to show that 10x is equal to 4 upon 3. We also know we are dealing with an arithmetic progression, so we also know that the first term is 2 sine x, the second term is 3 cos x, and then the third term is all of sine x plus 2 cos x. And what is important is that the first term can also be denoted or represented by the letter A. Okay, so when you're dealing with arithmetic progressions, you need to know what the common difference is. So the common difference you normally get by taking the second term minus the first term, which would be the same as the third term minus the second term, respectively, in that order. Okay, so when you subtract successive terms like this, you should be able to get something which is the same. So you just go ahead and replace that. And at the end of the day, I want all my cosines on one side and all my sine on one side. So eventually you should get to 4 cos x is equal to 3 sine x. Right, so we're not done here because we are supposed to show that 10x is equal to 4 upon 3. And when you divide throughout by cosine x here, this is going to leave you with 4. And then the sine x over cos x is nothing but 10x. So we're nearly done. Basically, you now have to make 10x the subject of the formula. Therefore, 10x is equal to 4 over 3. You're going to use this in order to find the first 20 terms and the very important information about an acute angle. Okay, so that's the formula, and remember, use the correct sum formula for the correct progression. This is arithmetic, so I use S sub n equals to n upon 2 multiplied by 2a plus n minus 1 times the common difference. So we need to find what the common difference is, hence why we calculate the value of x. Right, so that means you're going to find the inverse. I'm going to give my answer in degrees, about 53.13 degrees. Tangent is positive in the first quadrant as well as in the third quadrant, but it's an acute angle, so we are just looking at 53.13. So my common difference would be just substitute. Like for example, I took second term minus the first term, I get 0.2000, which is about 0.20. And then I need to find what my A value is, right? So my A value, my first term, 2 sine 53.13, gives you about 1.60. Now you have your A and your D. You can go ahead and substitute them in order to find the sum of the first 20 terms. So correct substitution, and then you can punch it in with your calculator. You should get that the sum of the first 20 terms is nothing but 70.